number 9. This is the QAS test from April 2017. And question 31 says, which statement is supported by data represented in the table? So here's what we need to do. We should probably go back to the table to begin with. And what we want to do is we want to look for what is going on in this table. Just sort of get a basic layout of what the graph and what the table is measuring, and then we can go back to 31 to answer it. So the table is measuring properties of selected solar system objects. So we have the different objects listed here, and we have a few different things. We have average distance from the sun. We have the radius being measured in terms of Earth. We have the mass in terms of Earth. And we have the average density. So we don't really know, can't really say in advance. There's nothing we can answer to answer 31. We have to just go through the statements one by one and see which one is supported by the table. So A says Earth shows greater variation in density than Ceres does. So we go back up to this passage here, we look for density, and we look at Earth and we look at Ceres. So Ceres has 2.7, what is this? Grams, I guess, per cubic centimeter, and Earth has the same thing as well, grams per cubic centimeter. We see the difference there. However, the question is asking about variation in density, which would mean how it changes over time. And this is sort of like a snapshot. This is not talking about changes over time. So there's no way to measure variation, so we know it can't be answer choice A. B says Juno's average distance from the sun is less than that of Ceres. So Juno is closer to the sun than Ceres, so let's look here. Average distance from the sun, Juno is here, Ceres is here. And we actually find that this is actually kind of pans out. Juno is closer to the sun by just 0.1, right? By 0.1 Earth's distance. So Juno's is less than that of Ceres. Sure, that works. C says some objects in the asteroid belt are greater in mass than Ceres is. So here is Ceres, here's the mass for Ceres. And then we have some objects in the asteroid belt. Really, the only one other object in the asteroid belt that's here is Juno, which what Juno is 0.0003, it's less, right? Ceres is 5 times as big in mass, in terms of Earth mass, 5 times as big as Juno, which is the only other objects that's in the asteroid belt. So Ceres is not smaller, or other objects in the asteroid belt are not greater in mass, so C is wrong. And then D, no other dwarf planet has a radius as large as that of Ceres. So we'll go up here, we look at the radius. Here's the radius for Ceres, that's a dwarf planet. The other dwarf planet is here, which is Pluto. Pluto is 0.2 Earths, this one is 0.073, so this is less than half. Ceres is less than half of the radius of Pluto in terms of Earth, and that means that D cannot be right because Pluto has a radius that's as large, or actually larger than that of Ceres. So D is wrong, which is going to leave us with answer choice B for our correct answer for question 31.